In this section, we are going to discuss another example for secant method. Here we are supposed to find out the solution accurate to within 10 to the power minus 4, which is 0.0001. And we are supposed to find the root for the function x cubed plus 3x squared minus 1. And we are given the initial guesses as minus 3 and minus 2. So this is our secant method formula. So what we're supposed to do right now is find out what is f of xn, which is f of, for us this is, let's say, x0 and this is x1. So basically this is xn and this is xn plus, or sorry, no, let's write it. So here we have xn minus 1 and here we have xn. All right, now we are supposed to find out f of xn, which is for us x1, or let's say it's minus 2. So here f of minus 2, using our equation or function, we have here x cubed, so we have minus 2 cubed plus 3 times minus 2 squared minus 1. So we have here minus 8 and plus 12 minus 1, which is equal to here 3. And then let us find out f of xn minus 1, which is f of minus 3. So here now we have minus 3 cubed plus 3 times minus 3 squared minus 1. So minus 3 cubed is minus 27. And then we have minus 3 squared is 9. 9 times 3 is 27. So we have a plus 27 here, and then we have minus 1. So those both will cancel and we'll have here only minus 1. Now we got f of xn, f of xn minus 1. What we're supposed to do next is now put all these values in our secant method formula and find out what would be a result. So here we have now x2, or we can say it x plus 1 itself. So xn for us is, as we told, I would just erase this again and write it more neatly maybe. So here, let's call this xn minus 1 and this as xn. So that's more clear now. Now xn is for us minus 2. And then we have minus f of xn, which we just found out here was 3, times we have xn, that's minus 2, minus xn minus 1, which is minus 3. And then we have f of xn, which we have here is 3. And then we have minus f of xn minus 1, that's minus 1. So we'll write it here like that. And now when you solve this part here, what you get is minus 2.75. Alright, so that's our first value for xn plus 1. And now what we can do is we can find out what would be f of xn plus 1. So that would be, now putting minus 2.75 in the equation, we have minus 2.75 cubed plus 3 times minus 2.75 squared minus 1, and that gives us the value as 0.89 0.0625. Okay, so now let's go ahead and put all these values in our table. So I've drawn the table in the next page here. So this is what we were working on, was iteration 1, and our xn minus 1 value was minus 3, xn for us was minus 2, xn plus 1 that we found out was minus 2.75, and then we had f of xn plus 1 that we found out just now, that was 0.890625. Okay, now very important here is to find out the difference between xn plus 1 and xn, because based on that we'll stop, because as the question says here that we find our solution accurate to within 10 to the power minus 4. So when the value here, when you subtract the xn plus 1 and xn, when the value here is less than 0.0001 or 10 to the power minus 4, that's the point we stop. So what we do here, we find out the absolute value of xn plus 1 minus xn. So that would be minus 2.75 minus 2, that would be plus 2. So minus 2.75 plus 2 will give us the value here as 0.75, the absolute value. Okay, now let's go ahead and go for iteration 2. Now for iteration 2, maybe it's better I work it out here itself. So for iteration 2 now, our xn minus 1 is now our xn. So the minus 2 is here, and our xn will be xn plus 1 now. So here this will be minus 2.75. Okay, so our xn minus 1 and xn has changed. So when we use those two and we put in our formula right now, so here let me copy the formula, or maybe just not copy the formula, or just try to find it out here directly. So we have xn plus 1 is xn minus f of xn times xn minus 1 divided by f of xn minus f of xn minus 1. Alright, so here now, to find out xn plus 1, we need for the second iteration. So here we are working on the second iteration. Okay, so for us now, xn plus 1, our xn is minus 2.75 minus f of xn, that is f of xn, which is f of minus 2.75 is the value that we found out here. So that is 0.890625 times, we have xn, which is minus 2.75 for us in the second iteration now, minus xn minus 1, which is minus 2, divided by, we have f of xn, that is 0.890625, minus f of xn minus 1, that's f of minus 2 that we found out in the previous page here. So that was f of minus 2 here, which is 3. So that value, we'll use it here, and this will give us the value as minus 3.066667. Okay, that's up to 6 decimal places. So here now we have minus 3.066667. Now if you put the value of xn plus 1 in the function, the value that we get now is minus 1.626963. And then now if we subtract minus 3.066667 66667 minus 2.75 here, we will get the value here as 0.316667. Okay, now let's go ahead and do the third iteration. So in the third iteration now, our xn becomes xn minus 1. So here we have minus 2.75, and our xn plus 1 is now our new x of n, which is minus 3.066667. And now to find out for the third iteration, again we'll use all the values here. So maybe I want to work it out here, so I'll copy the second iteration and put it in the other page so that it's not confusing here. So I'll keep the second iteration work here now, and we'll go ahead and do our third iteration now. So again, the formula is xn plus 1 is xn. So our xn now is minus 3.066667. Then we have minus f of xn, which is here we got the value in the previous second iteration, which is minus 1.626963 times we have xn, that's minus 3.066667, minus we have xn minus 1, which is minus 2.75 here, and then we subtract f of xn, that is f of xn is minus 3.0467, so that would be again the value there, which is minus 1.62692963, minus f of xn minus 1, which is for us f of minus 2.75, which we have previously here in blue, which is 0.890625. So once we solve this one here, what we get now is minus 2.862024. So we'll write that down here now. We have minus 2.862024. And if we put that value in the function, what we get is 0.130184. And now if we subtract s of x of n plus 1 minus xn, what we get now is 0.204643. So this is not yet lesser than 10 to the power minus 4, which means we still have to carry on our calculations. I wouldn't do it again and again showing all the calculations down here, but I'll just give you the numbers until we go down to the tolerance here, which would be less than 10 to the power minus 4. And yet again, I'll copy this third iteration from this page here and keep it in the other page so that here it's clear and we can work everything more neatly out. Okay. So now here, the fourth iteration will have now our xn minus 1 will be the previous xn, which is minus 3.066667, and xn plus 1 will be our new xn, that's minus 2.86 2024. So now xn plus 1, if you use the formula and find it out, what we get here now is minus 2.877186 here, and putting this value inside the function will give us 0.016679, and then subtracting xn plus 1 minus xn gives us now 0.015162. Now still we haven't reached below 10 to the power minus 4, so we continue on our work here and we go to the fifth iteration now. So here we have now our xn again here becomes xn minus 1, so here we're minus 2.862024, and xn plus 1 will become xn, which is minus 2.877186 here, and the new xn plus 1 using the formula will get now as minus 2.879414, and f of this value will be minus 0.000218 here, and xn plus 1 minus xn now gives us 0.00228. Okay, there is one more too because I just missed that one. Okay, now here we go to the sixth iteration because our value is still not lesser than 10 to the power minus 4. So let's go to the sixth iteration now. Here we have the new xn is minus 2.877186 here, and xn is minus 2.879414, and xn plus 1 now we get is minus 2.879385, and putting this value in the function now gives us here 0.000000 up to 6 decimal places, and xn plus 1 minus xn will give us now 0.000029. As you can see, this is less than 10 to the power minus 4. So once we come to this place here, when the value here is less than 10 to the power minus 4, what we do here now is we stop our calculations and we say that it's 0. You can say therefore the root of f of x is this value here, right, which is minus 2.879385. So that's the root of our function here using the secant method.